Hello, you're welcome back. Okay, so now we are looking at elastic collision. Okay, now as the name implies, after the collision, in elastic collision, after the collision, the two objects, okay, don't move in the same direction with a common velocity, but rather they will move in opposite direction. Okay, unlike in elastic, that after the collision they will stick together and move in one direction, but elastic collision actually causes the object to move in opposite direction after the collision. Now, for me to actually illustrate this, let's look at the rocket. Okay, this rocket proportion. Now, a rocket actually has an engine, jet engine inside of it. Okay, where chemical reaction actually takes place that causes the jet engines to issue high, okay, to issue gases at a very high velocity and of course momentum. Now the reaction here actually causes collision that will cause some gas molecule to be issued backward, okay, being an action. So that particular momentum that is being created by issuing this gas backward will now propel the rocket forward. That is reaction. Okay, so the reaction actually creates the reaction inside the engine actually create two forces. One is actually backward and the other one is forward. Okay, so and these two, the action and the reaction, is equal and opposite. So for example, let's say the mass of the gas that is actually being issued is m1, and the velocity of the gas that is being issued out with a very, of course it will go with a very high velocity, is v1. Okay, so now that particular action we actually create an equal and opposite reaction. So the minus, let's now let the mass of the rocket be m2. Okay, that's going to be minus m2. Then let the velocity to which the rocket actually moves forward be v2. So v2. So this is inelastic collision. Right, action is equal and opposite to reaction. So in inelastic collision we use this formula. So the minus sign shows that the action is equal and opposite to the reaction. Okay, so the minus is just an indication of direction. So if I'm solving question, I may not necessarily need to actually indicate or apply the minus here. So please take note of that. Let's look at typical example. One typical example of elastic collision is the recoil of a gun. Recoil of a gun. A gun fires bullets with a very high velocity. Okay, that's a reaction that actually takes place in the gun. Okay, where you have some explosive or also, okay, whatever you may have inside. So that when this trigger is being pulled, the gun actually releases bullet with a very high velocity. Okay, so creating a momentum, an action. And once that momentum actually is being created, okay, as an action, then an opposite momentum is actually created on the gun that will cause it to react. Okay, that reaction is what is known as the recoil of the gun. So the same formula goes, let's say the mass of the gun is m1, and of course, okay, let's start with the let's say the mass of the bullet. Since the action, I'm starting with the action first. The mass of the bullet is m1 and the velocity of the bullet is v1. Then the mass of the gun is m2, and the recoil velocity, we call it recoil velocity, the backward velocity of the gun, which of course is called recoil velocity, is v2. So according to the law of conservation of linear momentum, okay, m1 v1 is going to be equal to minus m2 v2. So let's see a situation where the mass of the bullet is basically, let's say this is just 0.1. okay, then the bullet leaves with a very high speed of 5,000 meters per second. Now, let's say you have a gun whose mass is probably like 100 grams. Okay, let's say, okay, let me in kilogram. Let's say you have a gun whose mass is like 0.7 kilogram. Okay, then I want to get the recoil velocity. So that means the recoil velocity is going to be equal to 0.1 times 5,000. That gives us 500. Then now divided by 0.7. So if I divide 500 by 0.7, what do I have? 500 divided by 0.7. That gives approximately 714. So the recoil velocity of the gun is going to be 714 meter per seconds. Okay, so that is how we apply Newton's third law. Okay, in the cases of elastic collision and inelastic collision. So other things you need to learn is actually the application of Newton's third law. We've talked about this recoil of a gun is an application. This other one I talked about, which of course is rocket propulsion. The movement of rocket is also Newton's third law. It's an application of Newton's third law. There are other applications which we might look at. Application to Newton's third law, we have recoil of a gun. I've talked about a jet engine. Even the rocket propulsion also uses jet engine, an engine that actually issues gas at a very high velocity to create a reaction that will propel the engine, okay, forward. All right, now a person walking. Now, how do you walk? Walking is another application of Newton's third law. Let's say this is someone that's trying to walk. For you to walk, you have to actually take a step. Okay, so how do you take that step? One of your leg, okay, actually one of your leg will press on the ground, presses on the ground. That pressing now will actually, as you press on the ground, that is the action. Okay, the ground actually withstand your weight, lift you, reacts to you. Okay, that actually pushes you up to move, to take the next step. So this is action, and of course this is reaction that actually pushes you up to take the next step. So a man walking is another application of Newton's third law. Okay, so we can actually look at more questions, and that will be in the next video. Okay, see you in the next video. Thank you very much.